And we'll start from current slide. And I think, let me review, did I make the announcements about college transfer days coming up in February? And about the great opportunity for a summer research program at either University of Illinois, University of Arkansas, or Howard University. Did I make that announcement? Okay. I've got the information here if you want to see it. The career fair is Wednesday and Thursday, the 12th and 13th of February, and the deadline for the research opportunity is the 15th of February. So please move on those if you are wanting to do it. And Ian came in, right? All right. Any questions on anything we've done so far? All right. Last time we had started evaluating some trigonometric functions, and these are some of our favorites, okay? And we did the example 1A. We were just about to do example 1B. So, if there are no questions, where would we begin to evaluate the 6 trigonometric functions for t equal 5 pi over 4?
Well, I would say first we have to identify where it is in the
Okay, that's a great idea. So let me get my pen set up. Okay. And do a unit circle here. T equal 5 pi fourths. Where are we, Waldo? Second quadrant. There's 1/4 pi, right? 2/4 pi, 3/4 pi, 4/4 pi. That's not the second quadrant, is it? It's the third quadrant. There's 5/4 pi. Okay? 1/4 pi past pi. Okay? So what are our coordinates at that point? Negative root 2 over 2. Why do I put another parenthesis? That's wrong. Okay. Negative root 2 over 2. Okay. There we have it. So then, can we write our 6 trigonometric functions? Let's start with sine of 5 pi over 4 is what?
5 over y. So it's
negative root 2 over 2. What's the cosine of 5 pi over 4? Second, the x value, which is? Negative root 2 over 2. And the tangent of 5/4 pi?
Y over 8.
Which is? Which is? 1. All right. Cotangent of 5 pi over 4?
Y over 1 over y. So 1 over...
No. 1 over y is your cosecant. This is cotangent.
X over y.
Okay, and what does that give you? Which is? 1. Perfect. And secant of 5 pi over 4 is?
1 over 8, so it's 1 over
which is what? Negative square root of 2. Perfect. Okay, and cosecant of 5 pi over 4? Negative root 2. Perfect. Way to go. Now, let me point out a few things to you. If you're in the first quadrant, what's the sign of all these? Everyone is positive. If you're in any other quadrant, you have 2 positive and 4 negatives. Okay? So, down here, the 2 positives were tangent and cotangent, and the 4 negatives were the others. Okay? That's going to happen every time. Now, I'm going to give you a acrostic, I guess it is, to sort of help you remember this. Okay? Which ones are positive? All students take calculus. If you go around counterclockwise of your unit circle, starting with that. Now, I've also heard it called All State Technical College. It doesn't matter what you call it, as long as you hit those in. All of your trig functions are positive in the first quadrant. Only the sine and its reciprocal are positive in the second quadrant. All the other four are negative. In the third quadrant, only the tangent and its reciprocal, which is cotangent, are positive. And in the fourth quadrant, only the cosine and its reciprocal are positive. The others are all negative. That's just a sort of a help. If you don't get this working out, you made an error somewhere. So that's just a little tool to help remind you. Okay. Want to do C. Can I erase what we got? Okay, hold on. Got it? Everybody got it? Okay. I'm going to have to go back and draw my unit circle again, but it's better than erasing. This time we're interested in t equal pi. Okay? Where are we, Waldo? Say again?
Left side, halfway through.
Okay, we're on one of the
Like in between the
yeah, we're on an axis line. There is where we are with t equal pi. See, t equal pi has pi. This is t equal pi. Okay? So, what are our coordinates there?
-1, 0.
Got it. Okay? So let's do the sine of pi.
Y. So
0. Okay? Cosine of pi.
it's so it's negative.
-1. Okay? Tangent of pi,
Y over X.
which is
0.
0. Perfect. Cotangent of pi,
Is X and Y.
undefined, because you can't ever divide by 0. Okay? Secant
1 over X.
of pi, which would be
Yeah, negative.
-1, and cosecant of pi,
1 over Y.
which is undefined again. Okay. So on the axes, you're always, come on back. Okay. On the axes, sine and cosine will always be defined everywhere. Everywhere. But then half of the other two will not be defined and the other half will. So that's another thing to keep in mind. If you're on the, I think they call them the quadrantal axes, which means one of the quadrant axes, then that would be the case. Sine and cosine will always be defined, and the other four, 2 will be defined and 2 will not. Okay. Just keep up with which 2. All right. Ready for, all right, here we go. I'm going to make a guess. Is it, oh, it's Nikhil, right? Okay. When you first walked in, I didn't recognize you, but we have one other guy supposedly added to the class, but I haven't seen him yet. Does anyone know Eddie Douglas Johnson III? All right, we're top of page 272 in chapter 4, trigonometry, 4.2, trigonometric functions of the unit circle, and example 1, top of page 272. And we're on the fourth part now. So let me erase what we've got here and draw another unit circle. Okay. Now, D part says t is equal to negative pi thirds. Where are we, Waldo? Second? Third quadrant? Fourth quadrant. It's down here. Okay? This is minus pi thirds. Okay? What is our coordinates there? That's the next thing we have to determine. The x you can almost guess. Second? 1/2. And then what is the y that goes with 1/2? Negative square root of 3 over 2. All right. Everybody agree that's where we are and that's the location, right? So let's start with our functions. What's the sign of negative pi thirds? Negative square root of 3 over 2. Did everybody see how we got it? Cosine of negative pi thirds. 1/2. Tangent of negative pi thirds, which would be okay, and that would be negative square root of 3. Perfect. Okay, cotangent of negative pi thirds. What would that be? It's going to be what? Okay, a little louder. You may have said it right. I couldn't get it. Square root of 3 over 3. Perfect. Okay. It's negative 1 over root 3. And if you rationalize the denominator, negative root 3 over 3. Okay. Secant of negative pi thirds is what? Which is 2. Perfect. Cosecant of negative pi thirds, which is negative 2 over root 3, which you could rationalize to make negative 2 root 3 over 3. Perfect. You don't have to rationalize, but a lot of times the book does, sometimes it doesn't. You know, it's sort of hard to follow. All right, any questions on that? Notice the pattern. Figure out where you are. Figure out your coordinates. Once you got your coordinates, you can write down your form. Now that's for these favorite t values, which, let me remind you, is pi 6, pi fourths, pi thirds, pi halves, and all the multiples of those, all the way around the unit circles. Okay? Those are the fairly easy ones. And again, remember my little rule. If you're in the first quadrant, everything's positive. Everywhere else, your 2 are positive. Here are the 2 positive. The other 4 are negative. And which 2 are positive? All students take calculus, the C, which is cosine, and its reciprocal. Those are positive. Does that make sense? All right. Now, for some reason, the book does a different order. I don't know why, but we'll go by that. Let's see how they do theirs. Starting with the A one, which we did last time. For each t value, begin by finding the corresponding point xy on the unit circle. Then use the definition of the trigonometric functions. So where t is equal to pi 6, it corresponds to the point root 3 over 2 is the x, 1/2 is the y. So from that, we can write all 6 trigonometric functions. And we did, and they are the sine of pi 6 is your y value, which is 1/2, The cosine of pi 6 is your x value, which is root 3 over 2. You're in the first quadrant, everything's positive. The tangent of pi 6 would then be y over x, which would be 1 over root 3. They wrote it out that way. But all you have to do, what I like to do is just draw my line here. Cancel out the 2's and get 1 over root 3, which is also square root of 3 over 3. Okay. The cotangent function is x. Oh, that's where you, oh no, they went to cosecant function. And this is what I don't understand, why they do it in this order. Yeah, what they're doing is now starting at the top and reciprocating, okay, which is fine, it's correct. But I like to sort of go around the circle that way and do, then cotangent is exactly reciprocal of this, then do up and that. But any way you want to do it, and this is 1 over y, which would be 1 over 1/2, which is 2. And then they do the secant function, which is 1 over x, which is 2 over root 3, which when you rationalize the denominator is 2 root 3 over 3. And the cosecant function, the tangent function, they do it in a different order, is y over x, x over y, which is root 3. Okay? Do all that, it gives you root 3. We did that last time. Any questions on it? All right. Now, the B part. When t is equal to pi quarter pi, that's the one we started with today. We found out we're over here in the third quadrant. Both of your values are negative, and they're both valued at root 2 over 2. Tells us it's quarter pi. And so the sine of pi quarter pi will be negative root 2 over 2. Cosine will be negative root 2 over 2. Tangent will be 1. Okay? So it's the same thing in the numerator and the denominator here. It's the ratio of sine and cosine. And those are exactly the same values there, which is 1. And I would go on to do cotangent. They go up and do cosecant. And the cosecant is 1 over sine, which is 1 over y, which is basically your negative root 2. The secant is similar, negative root 2. And your cotangent is exactly what your tangent was, because it's reciprocal of 1 is 1. Okay. Make sense? All right. All right, good deal. Maury is here. Okay. The C part, when t is equal to pi, this time you're on one of the, for the axes, okay? T equal pi is exactly the other half of your negative, is the negative x-axis, okay? So out there, on the unit circle, you'd be at negative 1, 0, and when you start doing that, your sine of pi being y would be 0. Your cosine of pi would be x, which is negative 1. Your tangent would be the ratio of those two, which is be 0. Okay? The cosecant would be 1 over sine, which is undefined. The secant, 1 over x, would be 1 over negative 1, which is negative 1. Your cotangent would be 1 over the tangent. Tangent was 0, that was undefined. And, oh yeah, they did all three. I forgot they. So, just like we got. Any questions? Okay, we're on the top of page 272, chapter 4, trigonometry, 4.2, trigonometric functions on the unit circle, and we were doing example 1. We had done A last time, and we just finished B, C, and D. Now we're going over how the book did them. So, same way we did pretty much. So I think the D one is moving clockwise because this was T is equal to negative pi thirds. You move clockwise pi thirds. That corresponds to the point down there. X value positive 1/2, the Y value negative root 3 over 2. And then just start writing down your trig functions. Sine is the Y, and that would be negative root 3 over 2. Cosine is X, that would be 1/2. Tangent is a ratio of those, which is the negative root 3 over 2. This is negative root 3, okay? Because 2's cancel out. Now they go to cosecant, would be 1 over the Y value, which is negative 2 root 3 over 3. The secant is 1 over the X value, which would be 2. And the cosecant is X over Y, which is reciprocal of the tangent, and that would be negative 1 over root 3, which would be negative root 3 over 3. Any questions? Does that make sense? These are fairly straightforward, but is there anything that's fuzzy to you? You don't know why they're getting something? All make sense? Okay. Now, there is a checkpoint. It's pretty easy stuff, but it takes a bit of time to write it all. So try to do the checkpoint as soon as you can after class. So let's move on to domain and period of the sine and cosine. First, remind me, what do we mean by domain? Input. All the possible input values you can have. Okay, we're only going to deal with sines and cosines. Any idea now what values you could put in for a sine or a cosine?
Real numbers?
All real numbers. There's no limit to what you can do. Remember, sine and cosine are defined everywhere, so all real numbers. Now, what do we mean by period? That doesn't mean end, like the little dot. This is the period that means all your trig functions are what we call periodic functions. They follow a certain period. Okay? This is circular sounding reasoning, and it is. So, what
is that period?
the period is the part of the cycle that repeats itself. That's the period. Okay? Because they're periodic functions, they repeat themselves every so often. The smallest unit that repeats itself is the period. So the domain, going back to what we said, of the sine and the cosine functions, set of all real numbers. Sine and cosine defined everywhere. To determine the range, now they didn't say that, but the range of those two, what do those come out being? Sine and cosine. Think about your unit circle. It starts 1 here, goes up to a 1 there, back to a -1 here, down to a -1 here, and back. Everything here, the range value goes between plus and -1. Okay? You can go round and round and round the circle as much as you want, but the range stays between plus and -1. Okay? All your tricks for your sine and cosine functions. Okay. Remember, your sine was the y values. They go between plus and -1. The cosine was the x value. It goes between plus and -1. Never gets outside of it. Neither one of them. Find everywhere, big or as small a t as you want to go. Find everywhere. Always say between plus and -1. Okay. So if you ever are looking for an angle or a t whose value is 1.7, hang it up. Always going to be between plus or -1. All right. So by definition, the sine, like I just said, is the y value. The cosine is the x value. The x value is on the unit circle, stays between plus or -1. The y value stays between plus and -1. So the values of the sine and cosine functions also range between plus and minus 1. Okay. The mains are real numbers, the range for both the sine and the cosine, plus and minus 1. That's the only values it can take up. Now, let's start with, say, the sine function. Here the y value is 0, it goes up to 1, y value goes down to 0, down to minus 1, and then back up to 0 again. Then it just goes through that same circle again and again and again. Or if you started going negative, starting the y value at 0, goes to minus 1, 0, plus 1, then you go through the same cycle again. So it's, I hope, fairly obvious that the period of a sine or a cosine function is going to be 2 pi because it repeats the cycle every 2 pi, right? Exactly repeats the cycle every 2 pi. So here, at this point, your x value, they're just saying the t. The t is 0 here, pi fourths here, pi halves here, 3/4 pi here, 5/4 pi, 3/2 pi, 7/4 pi, and 2 pi. So that's what they're doing. Going around and around, but every time you go around, you then add another 2 pi to what it was. It was pi fourths here, now it's 9/4 pi, okay? Which is pi fourths plus 2 pi. 2 pi is 8/4 pi plus pi fourths is 9/4 pi. So you just are adding 2 pi to each of these values as you go around. This is pi plus 2 pi. This is 5/4 pi, 5, and 5/4 pi plus 2 pi. Everything is adding 2 pi now. These two, they didn't say it, but this is 0 plus 2 pi, 0 plus 4 pi, and so on. So you're just adding another 2 pi every time you go around. Or subtracting if you're going in this direction. Okay? This whole point of this is showing it's always a multiple of 2 pi. Here, and here, here, here. Always add another 2 pi. You're back where you started, or back where you were, same value, 2 pi's ago. Okay. So the values of t plus 2 pi, sine of t plus 2 pi, and cosine of t plus 2 pi correspond to those of sine of t and cosine of t. Whatever t you choose, and you go one more circle around, you're at the same value for the sine, same value for the cosine. Okay? Similar results could be obtained by repeated revolutions, positive or negative, on the unit circle. So that leads to this statement. If you want to make as many revolutions as possible, put it in for how many revolutions? 7. So that would be t plus 14 pi is the same as sine. Yeah. Every 2 pi, you wind up at the same place. However many times you went around, n is the number of times you go around. And n could be negative going in this direction. You wind up at the same place. So what we say here, cosine of t plus 2n pi, 2 pi n, however you want to say it. For any integer n, these are integers, not numbers, just integers, and real number t, always true. So the functions that behave in such a repetitive or cyclic manner are called periodic functions. So they got to the periodic function first. Now they'll define what the period is. Did y'all need that a little longer? Okay. So definition of a periodic function. A function f is periodic when there exists some positive real number c such that f of t plus c is always equal to f of t. If there is some number c that's always true, then we say f is periodic for the period of c. Well, almost, we got that far. for all t's in the domain. The smallest c for which it's periodic is called the period of f. Okay. You could have said 17 pi. Yeah, that works too, but that's not the smallest. The smallest is 2 pi. Okay. For sine and cosine. We know that a function is even when f of minus t is equal to f of t. Y'all remember that? Way back in pre-calculus algebra. Okay? A function is even when f of minus t is the same as f of t. So if you go f of minus t here and have a value, it's got to be the same as f of t. That makes it an even function. Okay? It's an odd function when f of minus t is the opposite of f of t. Like this or like that. Okay? Even the f of minus t is equal to f of t. Okay? They have to be the same. Now from those two descriptors, because the cosine is the x value of your point that you are, then cosine of minus t going in this direction is the same as cosine here, because cosine is positive in the first and the fourth quadrant. So those are always the same. Secant, because it's reciprocal, same deal. But the sine, because the sine, all are positive here, and it's positive over here, but negative over here, then f of sine of minus t is the opposite of sine of t, because it's odd. Same thing is true of tangent, and then both the reciprocals of that would have to be the same. So 4 of them are odd functions, only the 2, cosine and secant, are even functions. Now we will use that a little in the future, not a big deal, but it is something just to keep in mind. Especially when you start drawing the graphs, then it's really nice to know. All right. I hate it when they give you all the answers in the problem. Okay. Here is 13 pi 6. What we want to know is what is the sine of 13 pi 6. Now, I don't keep that in my head. But what I can do to determine it is subtract 2 pi, because that's the period for sine. Well, how many 6 of a pi is 2 pi? Say again? 12. 12 6 is 2, isn't it? Okay. So 12 6. So subtract 12 6 from 13 6, and what do you have? Pi 6, right? Well, what's the sine of pi 6? Sine of pi 6 can't be sine of pi 6. Say again?
2 pi plus pi 6.
What is the sine of pi 6? Okay, that would be sine of pi 4. Sine of pi 6. 1/2, exactly. Okay. So that's what we're doing here. I thought they had the answer, and they don't. Okay? What we're saying here, 13/6 pi, that's a big number. So let's subtract 2 pi from it, and you get pi 6. So the sine of 13/6 pi is going to be, of course, 13/6 pi is this, but that, because 2 pi is the period, subtract off the 2 pi, and that's the same as the sine of pi 6. And the sine of pi 6 is 1/2. Okay. Remember, pi 6 is that little angle here. You've gone up y 1/2. Down here would be square root of 3/2. Again, need too much. Where are you if you're at negative 7 halves pi? Let's add 2 pi to that. How many half pi's is 2 pi? How many half pi's is 2 pi? How many halves is 2?
Is it 9 pi over 8?
Okay. I'm not sure how you got that. Okay. How many half pi's is 2 pi? Okay. It may not make much sense why I'm asking this. How many halves are in 2? 4. 4 halves is 2. So how many halves are in 2 pi? 4 pi halves, right? 4 pi halves. So add 4 pi halves to 7 halves pi, and what do you get? Add 4 halves pi to minus 7 4 halves pi. Add 4 halves pi. That gets you one time around problem. Is how much? 3 halves pi. Negative 3 halves pi. Okay, now I can find that on the thing by going negative 1 half pi, 2 halves pi, 3 halves pi. Or add another 4 halves pi to negative 3 halves pi, and you get pi halves. Either way, that's what you get. If you like their way of doing it better, that's fine. I like to add the 4 pi to it to see what you wind up with. Add 2 pi and then add another 2 pi. They said this is minus 4 pi plus pi halves. I don't think that way, but if you think that way, that's perfectly fine. So therefore, if that's what negative 7 halves pi is, and you're wanting the cosine of negative 7 halves pi, then that's the same as the cosine of negative 7, but negative 4 pi plus pi halves. Well, you know this is the same as, because this is a multiple of 2 pi, even though it's negative, this is what you use. And what is the cosine of pi halves? Anyone know? Second, 0, exactly, because it's 0. So that's cosine of pi halves, and cosine of pi halves is 0. Because at pi halves, the x value is 0. Okay? Does that make sense? All right. Let's start with the unit circle again. Okay? Now, 13/6 pi. There's 1/6 pi, 2/6 pi, 3/6 pi, which is half pi, 4/6 pi, 5/6 pi, 6/6 pi, which is pi, 7/6 pi, 8/6 pi, 9/6 pi, 10/6 pi, 11/6 pi, 12/6 pi. Okay? Well, 13/6 pi would be one more. So there you are. That's the same as pi 6. This is the same as that, so it's sine of pi 6. I don't know why the 6 didn't write, but it didn't. Okay. That's one way to do it. Okay. Down here, what I think I'll do is erase okay. This time, this is just giving me another way to do it. Negative 7 halves pi. That's negative 1 half pi, negative 2 halves pi, negative 3 halves pi, negative 4, negative 5, negative 6, negative 7. There's where you are. And that's the same as pi halves, right? Negative, you go around this way. Every quadrant is half a pi, right? So that gets you right there too. So that gets you the same place that that did. wow, where did this come from? Now, for sine of t equal 4/5, what is sine of negative t? What would that be? Sine of t is 4/5. What would sine of negative t be? Negative 4/5, because sine is an odd function, and the sine of a negative is a negative function, okay? Because sine is odd. That was just pulled in here out of nowhere, it seemed like. Maybe I should turn the page so I can see where they're getting these. Okay. The first two were just going around the unit circle. The third one was just checking if you understood what even and odd functions were. Okay. That's example 2. There is a checkpoint after example 2. Now, what if it's a function, what if it's a value that's not one of our favorites? Like 0, pi 6, pi quarters, pi thirds, pi halves, and then any multiple of those going around and around in either direction. Well, those are the only ones we really know right off the top. There are plenty of more angles in between there, or values for t in between those. So when evaluating a trigonometric function using a calculator, be sure you're in the right mode. Most of what we've been dealing with has been in which mode? Radian mode. So if your calculator's in degree mode, you do your trig functions, you're going to get way wrong answers. Or if it's in radian mode and you're entering degrees, you're going to get totally wrong answers, okay? So be sure the first thing you do, make sure you know what mode you are, which units you're using, and get into that mode, okay? Degree or radian. Most calculators do not have keys for cosecant, secant, and cotangent functions, okay? To evaluate those functions, they say use the x to the minus 1 key. On some of the older calculators, it's the 1 over x key, okay? Because those are reciprocals of the cosecant is reciprocal of sine, the secant is reciprocal of cosine, and the cotangent is reciprocal of tangent. That's why I've been using that word all along. They sort of just throw it out at you now. But if you think about it, cosecant is 1 over y, sine is y. Secant is 1 over x, cosine is x. Cotangent is x over y, tangent is y over x. There's the reciprocals of each other. So that's why you use the reciprocal key, which in some calculators is 1 over x key or whatever. Okay. So with those two concepts in mind, let's do some. For example, to evaluate the cosecant of pi 8ths. Anyone got a calculator? Okay, do any of you know what a trig function for pi 8ths is? I don't. Okay? It's not one of our favorites. It's not pi 6, pi quarters, pi thirds, pi halves, or any multiple of those. Okay? So, what you're going to have to do is use a calculator, but your calculator isn't going to have a cosecant key on it, I don't think. Now, maybe some of you have really big, fancy, rich calculators, expensive calculators, that may have it. Mine don't, okay? So what I do, I know that the sine is reciprocal of that, so I first figure out what sine of pi 8ths is, and then hit the key. I wait until I do this, and then I reciprocate, okay? Or you can do it this way, 1 divided by sine pi 8ths, okay? Now, here's how they're saying. This is the shortest. The first thing you do before anything else, when you see pi 8ths, what mode are you in? You're in radian mode, okay? You have to have a degree symbol to be in degree mode. If you don't have a degree symbol, you're in radian mode. So make sure you're in radian mode. Then, what they say to do here is open parentheses, sine, and when you do the sine key, it usually opens another parenthesis for you. Then do pi divided by 8, close that parentheses, then close this parentheses, and then hit your reciprocal key, 1 over x, or x to the minus 1. And I don't even think you need to do that. Most calculators you don't. If you don't get the answer you're looking for, you do that. Now, is that a reasonable answer? 2.6131259. Way too many digits, but is it reasonable? I think I may have mentioned this before, but I'm going to mention it again. When you're doing a sine or a cosine of any angle whatsoever, that better come out to be a number between plus and minus 1. If it's anything greater than 1 or less than minus 1, you got the wrong answer. Something's wrong, okay? Now, the reciprocal functions of those, secant and cosecant, or cosecant and secant, when you do those, you're going to start at plus 1 and go up, or minus 1 and go down. They'll never have an answer between plus or minus 1. Okay? They're always going to be outside of it. So this is a very reasonable answer for cosecant. Now your tangent and your cotangent, they can be anything. They can be anything from minus infinity to positive infinity. There's no sort of check on those. A sine or a cosine always going to be between plus or minus 1. Secant and cosecant are always going to be outside of plus or minus 1. You understand what I mean by that? Tangent and cotangent could be anything. Okay. So let's do example 3. I hate it, and they do too much of a problem for you. When you see that, what mode do you think? Radian mode. So, what do you, in the South we hit the keys. Other places we press the keys. We're going to hit the key. When you hit sine key, it's going to open a parentheses for you. So you hit the sine key, it opens a parentheses for you, and then you type in 2 pi divided by 3. Close that parentheses, and I don't even know if you have to do inner or not, or equal. You probably do. Is this a reasonable answer? Yes, it's between plus or minus 1. That's reasonable. If that had been 1.866, you did something wrong. Your calculator screwed it, okay? Something is off. Sine can only be between plus or minus 1. Did you do it on yours just to see how it works? What's that? Okay. I want you to be familiar with your calculator. Know the syntax. Not all calculators use the same sequence of keystrokes. Make sure you get that answer when you do sine of 2 pi, 2/3 pi.
I don't know how my calculator got 0.03656.
Okay, say that one more time.
My calculator got 0.03656.
Ooh, okay. 0.0. Wait,
But I put in seeing.
are you in radian mode?
I don't know about all that.
You always check your mode first. Were you?
I believe most
You know how to get there?
Seeing close to 10 on mine.
What's that?
I got seeing close to 10 on my calculator.
I can't hear, sorry.
I have seeing close to 10 on my calculator.
Okay.
Nothing, I probably use my cell phone.
Okay, no, okay, wait. All right. Let me watch you put the thing in. Do your, press the sign key. Yeah, you get a sign key. Open the parentheses for you. Do 2 pi divided by 3. Close the parentheses. Okay, look at that. DEG, the read mode. Before you change, okay, go to the mode key. Okay, and you see that degree, radian, or grad. We don't use grads. So over 1, press enter. Enter. Okay. Now go back to, or go back clear. Okay, now try. Look at this. RAD, you're in radian. Okay. That's it. All right. Anyone else failed to get what they did? Always do your mode first, and then you go from there. Okay? Now, what if you had cotangent of 1.5? What mode are you in then?
Degree.
Okay?
Over.
You're in radian. If you do not see a little degree sign there, you're in radian mode. So be sure you're in radian mode. Now, have you found your cotangent key? You're not going to find a cotangent t on most calculators. So what do you use?
The big X and the minus 1.
Okay, you could either do 1 over tangent of that, or you could do tangent of that to the minus 1. Okay, so your mode is still radian, and then what you do is the tangent key, the way the book's going to do it, that will open you up a parentheses, do 1.5, you close the parentheses, and then you hit the x to the minus 1 key, or the 1 over x key if you have an older calculator, something like that, and I think you're going to get your answer. If not, you may hit enter or equal. Okay. What do you get? Second? You got the same answer in the book? Okay. They got 0.0709148, blah, 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 blah. Okay. Anyone failed to get that? And frankly, it's almost as easy to do this. Cotangent, once you're in radian mode, of 1.5 is equal to 1 over, or 1 divided by tangent of 1.5. Yeah, what are you doing? And this is, my computer's just going a little nuts right now. Okay. All right. 1 divided by tangent of 1.5 equal. That'll give you the same thing. So if you don't want to use the 1 over x or x to the minus 1 key, you can do it that way too. Should get the same answer, right? Yay or nay? Okay. All right, that does finish, and there is a checkpoint, and please do your checkpoints as soon as you can after class. Let's do vocabulary. Each real number t corresponds to a point xy on the blank blank. Say again? Unit circle, perfect. Number 2, a function f is blank when there exists a positive real number c such that f of t plus c is the same as f of t for all t's in that domain of f. What is that called? A function t is blank when there exists a positive real number c such that f of t plus c is always equal to f of t for all t's in the domain of f. Periodic, exactly. Number 3, the smallest c for which a function is periodic is the blank of f, the period of f, okay? A function f is blank when f of minus t is equal to minus f of t. Say again? I thought I heard even. That's odd. When f of minus t is minus f of t, and blank when f of minus t is equal to f of t. That's the even. Okay. Odd than even, right. Okay, homework exercises. Do either 5 or 7, they're both a Calc Chat. Either 9 or 11, they're both a Calc Chat. Any of the odds, 13 to 21, they're all at Calc Chat. Any of the odds, 23 to 29, they're all at Calc Chat. 23 is at Calc View. Any of the odds, 31 to 35, they're all at Calc Chat. 31 is at Calc View. Any of the odds, 37 to 41, they're all at Calc Chat. 37 is at Calc View. Any of the odds, 43 to 47, they're all at Calc Chat. Okay? Do 49. That's a Calc Chat. Should be. Then either 51 or 53, they both should be at Calc Chat. There is a conjecture. If you want to do it, you can. At 55, it should be at Calc Chat. And then there's an error analysis, 57. Now, I kind of don't like the error analysis because it's giving you a wrong answer. But then they put a big red X to tell you it's a wrong answer. But what you're to figure out is you figure out how that classmate made the error. Okay? Now, I can almost answer that one right now. And I bet you Angelica can too. Huh? How they came up with that wrong answer? They were in the wrong mode. I bet. I don't know that for sure, but you can check into that. And then using technology, if you have a graphing calculator with radian and parametric modes, I don't have one, so I'm not going to require it. And then, but if you have one and want to play with it, go for it. And then 61, you can think about doing that if you're interested. All right, let's move on to 4.3. So let me, oh, wait. Sorry. We did that answer. I didn't let you see what they did. Cotangent of 1.5. Because you do not see a degree symbol, you stay in radian mode, and then you, now here's the thing you have to remember. If you're doing it their way with that reciprocal key, you have to initiate with a parenthesis. If you do just tangent of 1.5 and then hit this key, it's going to reciprocate this, not the tangent. You have to have the tangent in parentheses to reciprocate it. So that's why they do it. And frankly, that's more keystrokes than just doing 1 divided by tangent of 1.5. That's why I'm lazy and do that. Okay. This one you have to enter both parentheses, hit that key, and then get it. So I think y'all said you got that answer. Okay. That's the end of the slideshow for 4.2. Let's go to 4.3. All right, we got what? 15 minutes, right? Takes almost that long for PowerPoint to open. Not quite. Okay, here we go. And we'll go from current slide. Goodness gracious. Still in Chapter 4, Trigonometry. 4.3 is right triangle trigonometry. Finally, we got triangles in trigonometry. That's where the name comes from. The study of triangles, the measurement of triangles. Okay? Here are the objectives here. We're going to evaluate our trigonometric functions of acute angles. Now, what do we mean by acute angles? Between 0 and 90 degrees or 0 and pi halves. And we'll use a calculator to evaluate some trigonometric functions. We just did that. We'll do a few more. We'll use the fundamental trigonometric identities. We've already mentioned a few of these. We're going to identify them now. And we'll use trigonometric functions to model and solve some real-life problems, which we always love to do. Okay? So, Using right triangles, we're going to identify our 6 trigonometric functions. This section introduces the trigonometric functions from the right triangle perspective. Okay? So let's consider, what do we mean by a right triangle? One of the angles is 90 degrees or pi half. Exactly. So let's consider a right triangle with one acute angle labeled theta, as shown below. Now, the acute angle would be one less than 90, so this angle is going to be your theta. There's your right angle, so the thing up here is going to be something else. Okay? We don't need to know it now. We'll run into that later. Now, relative to this angle theta, even before that, the angle opposite the right, the side opposite the right angle is always the hypotenuse. Always the longest side. Why? Because this one has to be acute, that one has to be acute, because the sum of the 3 is 180 degrees. And if that one's 90, 90 from 180 is 90, you got to divide it into 2 other angles. They both got to be less than 90. Okay? So they're both acute angles. Okay? So this is what makes that the longest side, because it's the side opposite the biggest angle. Okay? That we call the hypotenuse. Now, relative to this angle, this side is opposite that, and this side is adjacent to that. The hypotenuse is always adjacent to that, but we already identified the hypotenuse. That's the side opposite the right angle. So this is a side opposite the angle theta. This is the side adjacent to the angle theta. Okay? Now, with those identified sides in mind, here's what, well, I was going to give it to you. Let's go and let them give it to you. Using the lengths of those 3 sides, now these can be huge angle triangles, they can be tiny triangles. Doesn't matter what side. You can form 6 ratios that define the 6 trigonometric functions of that acute angle theta. Okay? Here are those. Again, sine, cosine, tangent, cotangent, secant, cosecant. Okay? Now, I'm going to tell you, relative to, let me get my pen back. Okay. Relative to this angle theta here. This is the opposite side, the adjacent side, and the hypotenuse. I'm lazy. I'll just write the first letter. Okay? You got what my symbols are, right? Here's what the sine is. The sine of that angle theta is opposite over hypotenuse. Always. The ratio of the opposite side to the hypotenuse. The cosine of that angle theta there, is the ratio of the adjacent to the hypotenuse. Adjacent over hypotenuse. The tangent of that angle theta there, is always opposite over adjacent. Okay? Now, those are the main 3. The others are reciprocals. So the cotangent of that angle theta would be adjacent over opposite, just the reciprocal of tangent. The secant is reciprocal of cosine, so that would be secant theta of theta. Secant theta will be hypotenuse over adjacent, and cosecant of theta is hypotenuse over opposite. Now, what I want to point out to you is this. If we were dealing with unit circle, the radius would always be the hypotenuse. And what's the radius on a unit circle? 1. So if you put a 1 in here, then what you have is your y value is the opposite side, your x value is the adjacent side. So this gives you y, that gives you x, this gives you y over x. That gives you x over y, This gives you 1 over x, and this gives you 1 over y. That's the same deal. The thing is, if you're dealing with a unit circle, the h is always 1. The o is always y, and the a is always x. You get the same formulas you had before. This time, you're not restricted to one size. Any size. It's tiny, huge. It works. The ratios work. Okay? Now, I don't know how y'all are remembering things. To me, I can remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. To me, that's not hard to remember. But the first time I taught trig class here, we were at Western State Technical College, and it was technical trig class. I believe it was the very first term. A gal who sat right back there, the same classroom, said, "Oh, some old hag caught another hag taking oats away." I've never heard that before in my life. But she said, "Oh yeah, that's how they taught us in school to remember that." Fine, it works. A couple of terms later, I had another gal that said, "Some old hen caught another hen taking oats away." Now, I like hens better than hags, so I go with hens, okay? However, and hens eat oats, so that made more sense too. So anyway, hags eat oats too, I guess. I don't know that many hags. I had a roommate in college. I was in grad school, he was an undergrad. And he did this one, and I've heard people do it. He said, "Sa, ka, toa." Okay? Now, to me, sa and ka, I had to remember which was O and which was A. Now, I've had somebody else say, "Oh no, I always wanted it. So, ka, toa." That way you can remember better. You don't have to distinguish between an O and short O and short A. They said long O. So, ka, toa. If that's helpful for you, use it that. Or just remember sine is opposite over is hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay. Now that's my little rules. Let's see what their goals. Here they do. The following definitions. In the following definitions, it's important to see that as long as you're an acute angle between 0 and 90, or 0 pi halves if you're in radian, that theta lies in the first quadrant, and that for such angles, the value of each trigonometric function is positive. First angle, all trig functions are positive. So let theta be an acute angle of a right triangle. The 6 trig functions of the angle theta are defined following, and note that the functions in the second row are reciprocals of the ones in the first row. Now we're doing like I like to do. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, cotangent is reciprocal of that, adjacent over hypotenuse, secant is reciprocal of that, hypotenuse over adjacent, and cosecant is reciprocal of sine, which is hypotenuse over adjacent. Now, remember what I said about the relative sizes? Sine and cosine are always between -1 and 1. Okay. In the first quadrant, they're always between 0 and 1. Okay. The reason is the hypotenuse is always longer than the adjacent. Okay. So if you're at 0 degrees or 90 degrees, at 0 degrees, this is 1. At 90 degrees, this is 4. Okay. And the reciprocals, because hypotenuse is always greater than the opposite or adjacent, these are always greater than 1. Okay? And on the angles they can be. But tangent and cotangent can be any size, because the opposite side can be very short and the adjacent side very long. That can be a very small angle, or opposite can be very tall and the adjacent side very short. That can be an enormous tangent or cotangent. Okay, these represent the lengths of the 3 sides. Opposite is the side opposite theta, adjacent is the length of the side adjacent to theta. Hypotenuse is always the length of the hypotenuse, which is opposite the right angle. Okay. Any questions on that? Okay. How are we doing on time, okay? So, okay. 11:11. So we've got 4 minutes. Let's see if we can do example 1 in 4 minutes. Okay. Use this triangle in this figure to find the value of all 6 trigonometric functions of theta. Okay? Sine of theta, cosine of theta, tangent of theta, cotangent of theta, secant of theta, and cosecant of theta. Okay? They give you, which is this side called? The 3 is the adjacent side, 4 is the opposite side. Uh-oh, they forgot to give us hypotenuse, didn't they? Can we do this problem? Yes, you can. Pythagorean theorem. A squared plus b squared, which in this case is o squared, has to equal c squared, which in this case is h squared. So what's 3 squared? Plus 4 squared? 16. 9 plus 16 is? 25. Square root of 25 is? 5. A 3, 4, 5 triangle. That's one of those Pythagorean triplets. Nice to remember those. Okay? So now we know the hypotenuse. So what's the sine?
Sine opposite of hypotenuse.
Okay, which is? 4/5. Cosine is? Adjacent over hypotenuse, which is? 3/5. Tangent is? Opposite over adjacent, which is? 4/3. Cotangent is? Adjacent over opposite, which is? 3/4. Secant is? Hypotenuse over adjacent, which is? 5/3. And cosecant is? Which is? 5/4. Okay? And guess what? These two are less than 1. One of these is less, one is greater. Have control over those. These two are greater than 1. Okay? That wasn't that bad, was it? So let's see how they did it. Let me erase what I did. First, you have to use the Pythagorean theorem to determine that the hypotenuse is 5. Y'all did that very nicely. And then fill in the blanks. Okay, use the formula. Sine is opposite over hypotenuse, which is 4/5. Cosine is adjacent over hypotenuse, which is 3/5. Tangent is opposite over adjacent, which is 4/3. Just put the division line there, and that's 4/3. The cosecant is hypotenuse over opposite, which is 5/4. Secant is hypotenuse over adjacent, which is 5/3. And cotangent is adjacent over hypotenuse, which is 3/4. Y'all did it very nicely. And what time is it? Have we run out? Huh? 15 on the nose, so we'll start next time. Let me get my pen. We'll start the pencil, I mean. Where are we, Waldo? Okay. By the way, there is a checkpoint to do it. Okay. They're skipping example 2. So we're going to go back and do example 2. So we won't be on that slide. We'll start with example 2 next time. And homework exercises in 4.3. You don't have many because we just got started. I think you can do any of the odds 5 through 9. They're all at Calc Chat. 5's at Calc View. I think you can do either 10, 11 or 13. They're both at Calc Chat. And we'll pick up the rest of those next time. Okay? Good deal. One more thing. Have a good weekend. Of course, working trig problems will make it good, won't it? Yes. Okay. So, sock it to it.